Good morning, everyone. Hope you had a good weekend. I'm Stuart, the ExamSolutions guy, and it's good to see many of you already on and waiting for this session. So we had a slight change of plan this morning. Okay, a lot of you who have come here before know that Michael has been doing the GCSE workouts, and there was a slight problem this morning. He contacted me and said that he had a technical issue, so I'm stepping in for him. I have written out a quick kind of workout, and do bear with me if there are some kind of hiccups. Hopefully not, but you never know with these things. I haven't had too long to prepare for this one. However, anyway, what it's going to be on is simultaneous equations. It's not an in-depth study of simultaneous equations. It's just an introduction to what they are and the process of what we call elimination. I'm going to just call it, say, simultaneous one, and Michael will give you further work on Wednesday when he comes in, okay, and he'll carry on with this, okay. So I'm just going to look at simultaneous equations by elimination method. Now, some of you most probably could well have done this, and I totally understand that, but not only I hope you're going to get more out of this, though, nonetheless, okay? So we'll be looking at that. Now, Michael has changed role for today. He's on the live chat. That's Michael from Air Maths Tuition, who's helping me out. So I can see he's out there, and he's already typing in some chat with you. So do enter into these conversations, okay? The point is, just want you guys to take part, okay? So I'm sure, as I say, many of you know what we generally do here. Okay, so what I'm going to do then, okay, we're just going to start off then. I'll just switch screens and we'll start this presentation off. Okay. Just want to briefly run through what a linear equation is, if you didn't know what it was. We talk about linear equations in one variable, all right? And this would be a typical one. Solve this equation here, 2x plus 5 equals 13. This is a linear equation. If you were to, because it's got one variable, it has the form, it's not got a squared in it, okay, here. So it's just a linear equation, as we say. And we would be asked to solve something like this, and I'm sure it shouldn't be too difficult for you guys. Does anyone want to just type in the answer at this stage? Okay. Just give us the answer to this one. Should all know it, okay. Be good just start a question for you. What is x? Okay, Guzila, I hope I've said that right, says x is 4. Anybody else? Okay, x equals 4. Adam is saying it's 4. Okay, so this is a typical linear equation, okay? Now, you guys most probably know how to do this, so I won't bore you with it, but basically what we do to both sides is to subtract 5 from both sides, okay? I've just put a little bit more detail in here. I'm sure you most probably would want to skip lines here, okay? But you 5 from both sides. That's going to leave you with 2x equals 8. Divide both sides then by 2. And again, I've put a little bit more detail in here. Those much detail given here, but just that idea. Now, what I want to turn to is where we have a linear equation in two variables, okay? Let's say we've got something like this, okay? Solve x plus y equals 3, all right? So maybe you might like to just quickly tell us what x and what y is, okay? I'll leave you to type in your answers. What is x? Okay. Let's have some answers for this, okay? what is x, what is y, and it equals 3. Hope you're not confused by this one. Nice easy one out there. Tell us what x and y is. Okay, x plus y equals 3. What's the solution? Is there a solution? You seem to be taking your time, guys. Come on, this isn't that difficult, is it? Solve x plus y equals 3. This is interesting, okay. Okay, well look, come on, x, let's suppose x is 1. What's y? Anyone? If x is 1, what's y? Right, Gary's come in and said there's loads of solutions. Bushes said cannot solve as 2 unknowns. Interesting. Need another equation, infinite number of solutions. So is there a solution to this? There's not a unique solution. I could have 2 plus 1, that makes 3. X could be 2, y could be 1. Alright? I could have x is 3, y is 0. 3 plus 0 is 3. I could have some negative numbers. I could have x is minus 1 and y would be 4. In fact, there's an infinite number of solutions. There's not one solution for something like this. So that's quite interesting to see the reaction that I got there. Okay, so what about then if we had, for instance, this equation here, x minus y equals 7. Give me some values for x and y that would make that equal to 7. Just type in a pair. Okay, we could solve that, surely. There are an infinite number of solutions, but give me a pair of values that would work for that. Anyone? Just pick on. All right, we've got Bushy coming in with 8 and 1. 8 take away 1 is 7. Good. 9 take away 2 from Adam would give us 7. Amber, x is 10, y is 3. 10 take away 3, 7. That's great. Okay, this, if you're not aware of this, there is a delay before I get the comments that you put down here. This is the nature of the live stream going through YouTube. So do bear with me on this if I don't answer your questions immediately. Good to see you, Ray. Okay, so this brings us then, if you haven't guessed already, what is a simultaneous equation? It's a pair of equations, something like this, where if we just take one equation here with variables x and y, we get an infinite number of solutions. And if the other one is not a multiple of the previous one, we will get a unique solution. So the idea of a simultaneous equation then is that we're looking for a pair of values that work for both of them. So if you thought that 3 and 0 works for the first one, which indeed it does, x is 3 plus y, which is 0, gives us 3. 3 take away 0 doesn't give us 7. So if you haven't guessed already, as I say, do any of you know what that solution is? Okay, what is that solution? If you've done simultaneous equations, as what this is called, okay, you might well already know how to do this. Okay, I'll be running through this for the benefit of those that haven't done this in the past. Okay, but I just want to make that point about what a simultaneous equation is about. Okay, find a set of variables that work for, in this case, both of these equations. So you might well be working ahead, okay, to try and get that solution if you have done this kind of stuff in the past, which I'm sure, as I say, many of you have. Who will be the first to come out with an answer? While I'm waiting, I'm going to take you through the methods, okay, if you haven't done it. What we do is we number the equations 1 and 2, all right, in a situation like this. And what we need to do is eliminate one of the variables, because if we eliminate one of the variables, we get an equation like this in one variable, as we did in the first example. Okay? And with that, we should be able to solve it. Okay, so I can see an answer coming in from Din at x is 5, y is minus 2. Leave you with a bit more time on that if you're doing it. Anyway, back to this. We have two equations here. I've numbered them 1 and 2, and what we want to do is eliminate one of the variables. And with a question like this, we can do it in two ways. Okay? We can either subtract the two equations from one another, and this would eliminate the x and give us an equation in y's. Or you could add the two equations and eliminate the y's and have an equation in x. And I'll show you this, that you can do it two ways. So if we were to add the two equations, okay, 1 add 2, we would get x plus x, which would give us 2x. The y's would cancel because plus y plus another negative y goes to 0, and we'd have 3 add 7, which gives us 10. So if we do add that, we end up with 2x equals 10. Okay? Now, all we need to do is divide both sides by 2, and we end up with x equals 5. Okay? And then we substitute x equals 5 either into equation 1 or into equation 2. It makes no difference which equation we go into, although it's better to pick the easier equation. There's not much difference in these. I would go for the first one though, purely because I like it's got positive signs in there. Normally easier to work with. So I'm going to sub x equals 5 into equation 1. If you do that, you'll see you get 5 plus y equals 3. And that, if we were to subtract 5 from both sides, gives us y equals minus 2. Now you didn't have to eliminate the x's, okay? You could eliminate the y's, okay? Because the y's will eliminate if we were to subtract the two equations. Could be careful here, okay though? If you do equation 1, take away equation 2, you'll find you get the x's cancel. X minus x here is 0, but here you got y minus y, okay? Y minus negative y, if you like, okay? And that's going to be 2y, okay? So if we just write that in, the 2y and 3 take away the 7 gives us negative 4. Divide through by 2 to both sides, you end up with y equaling minus 2. So we get the y value before we get the x value. And I can substitute y equals minus 2 either into equation 1 or 2. And if you do that, I've decided to substitute y equals minus 2 in equation 1, and you're going to get x plus negative 2, which is really minus 2, equals 3. Okay, so if you do substitute that in, there you go. You get x minus 2 equals 3, add 2 to both sides, and you end up with x equals 5. And always put a summary, by the way, at the end. If you're doing this on an exam paper, you'll have an area where you can write the summary in. X equals 5, y equals minus 2. Okay? So what I've tried to demonstrate here, and I can see, by the way, I'll just say what I'm trying to demonstrate here is the idea of solving simultaneous equations by elimination. And these are very easy simultaneous equations. They get harder than this if you're new to this. But at the moment, by adding, maybe by subtracting, we can eliminate a particular variable. Now, turning back to my other monitor here, and I can see that a lot of you had a go at this, and the answer was x equals 5, as we know, and y equals minus 2. So it's great to see that some of you out there had a go at that, and well done. I think I can see Guzila gave us the answer, x equals 5, y equals minus 2. Good. Just out of interest, by the way, if you were to sketch these graphs, they'd be straight lines. And the point of intersection of those two graphs would be at this point here, with the x coordinate of 5, y coordinate of minus 2. Okay? I haven't been able to display that. As I say, I haven't had much time this morning to produce this live stream for you guys, but that would be the case, okay? Right, okay, now what I want next, okay, go to another page, all right? So, I've got an equation here, simultaneous equation. A bit harder than the last one. It's not simply x and plus y. Here you can see we've got x plus 2y equals 6 and 3x minus 2y equals 10. Now, the key to doing simultaneous equations, the first thing you need to do is look for whether the x's are exactly the same or whether the y are exactly the same, give or take whether they've got a plus or minus, okay? And in a question like this, okay, we've got to decide, can we eliminate any of the variables? Can we eliminate the x's by adding or subtracting, or can we eliminate the y terms by adding or subtracting? What do you think? Okay, tell us what you would do. Okay, would you add or would you subtract these two equations? Okay, just enter that in quickly. Would you add them or subtract them from one another? I see that Adam said I use the method where you make both equations equal, the same thing. I take it you make x the subject or y the subject, and then you equate them to one another or substitute them in. Yes, you can do that. It's called the method of substitution. Sometimes it's a better method, depends on the nature of the equation. I'm sure Michael will tell you that a little bit more when he does his follow-up to this on Wednesday. Okay, so I see a lot of you guys have carried on and worked this one out, okay, and you are perfectly correct. If you said x is 4 and y is 1, well done. You do add the equations. That's the point that I wanted to make at this point on, okay. We would eliminate the y's here easily by adding the two equations. And you can do equation 1 plus equation 2, or even equation 2 plus equation 1. It makes no difference. You get exactly the same answer. So we're going to add the two equations. And if you do, you'll eliminate the y's. I've done 1 add 2, so it's going to be x plus 3x, which is 4x, and 6 add the 10 is 16. Doing plus 2y added to negative 2y gives 0. So we eliminate the y's. If I'd done equation 2 plus equation 1, what would I have got? 3x plus x, 4x, 10 plus 6, 16. Same thing, okay? Right, and then we know that from that, if you divide both sides by 4, x is 4. And I would sub x is 4 into equation 1, into equation 2. Again, it makes no difference. You can check it out. Providing you don't make any mathematical mistakes, you'll get the same answer. And if I substitute x equals 4 into equation 1, I'm going to get 4 plus 2y equals 6. Take 4 from both sides, 2y would equal 2, okay? Divide both sides by 2 and y equals 1, okay? Don't forget to summarize your answer. X is 4, y is 1. Again, just a reminder, if those two graphs were drawn, they'd be straight line graphs and they would intersect at x equals 4, y equals 1. Okay? Right. Now, what I thought I'd do very quickly now, okay, is just to give you this question here. All I want you to do, okay, is at this point, just tell me what you would do. Would you add the two equations or would you subtract the two equations? Okay, just enter that in. What would you do? Add or subtract? Adam says he would subtract. Anybody else? Yeah, okay, you would subtract. And the reason why you would subtract is it takes out the two 5x's, okay? Good, all right? So, if you would like to have a go at this one, have a go, all right? I'm just going to give you a short time to have a go at that one. Tell us what you reckon the answers will be then for x and y. Okay, have a go at that one. And for you guys who still this might be new for, okay, I'll be showing you the solution, albeit very quickly after this. Remember, you can always come back after this live stream and play the video back, pause it at various stages and try the questions in your own time, okay? I know you're working under a little bit of pressure here, but that's good, okay? I can see plenty of good responses here. You're all right. X is 3, y is 2, okay? Adam, I know I might be picky here. It's always a good idea to take x first though. X is, if it was a coordinate, for instance, x is 3, y is 2. I'm sure you'd be given the right mark. So you've made your answer very clear. But I'd encourage you to write x equals 3, y equals 2. Good, so that is the answer. What do you have to do then? You need to subtract your equations. So just check this out if you made a mistake. We've got here the 5x's will cancel, but minus 3y minus 2y. You've got to be careful there because that's going to be changed to minus 3y plus 2y, which is going to be minus y there. Okay, and 9 take away 11 is minus 2. Divide both sides by -1 or multiply both sides by -1. You're going to end up with y equals 2. Okay. If you did equation 2 take away equation 1, you can do it that way round. Again, you'll end up with the same answer. If you do equation 2 take away equation 1, the 5x take away 5x here disappears, goes to 0. Minus 2y minus 3y becomes minus 2y plus 3y. That gives you y. And then you have 11 take away 9, which is 2. So you'll get to y equals 2, most probably a bit quicker. If you did equation 2 take away equation 1. Okay, so anyway, I've got y equals 2, sub that into equation 1, and it makes no difference whether you put it in 1 or 2. I put it in 1. 5x minus 3 times 2 gives me the 6 here, equals that 9. And if you do the rearrangement of it, add 6 to both sides, divide both sides by 5, you end up with x equals 3. So summary then is x equals 3, y equals 2. Okay? Right, so I'm just going to give you a couple more, okay? We're going to go for this question here, and there'll be another one after this. Have a go at this one, all right? Decide what you're going to do and just go straight for the answer. And we'll have one more after this, then I've got a GCSE question that you might like to do. Okay, so we're looking at question 3 here. See what you're going to do. So we're looking for the answers on this one. Tomorrow, by the way, if you're working ahead, I'm going to be doing some pure maths and I'm going to be doing some integration. I'm going to be looking at one particular idea of integration. It's pitched at ASA level, standard, okay, and hopefully you'll be able to join in, and I'll give you some hints on the way, and hopefully you'll find it useful, especially even if you're thinking of going from GCSE to A level one day. I know these are difficult times. It might give you an idea of the kind of thing that you'll cover. Okay, so I can see some answers coming in now. We've got trying to see which question we're referring to in your answers here. I think we've got Adam then coming in with x equals 4, y equals 5, Dim with 4, 5, Gozelia with 4, 5. And it is, well done, x equals 4, y equals 5. The reason for picking this one, oops, yeah, that's right. The reason for picking this question was just to give you more variety in what we have to eliminate, how we eliminate it. Okay, here we've got a question with two negatives in here on the y terms. They're exactly the same kind of term. Okay, and when things are exactly the same kind of term, You always subtract to eliminate them, okay? Notice up here, these two were exactly the same type of term, the 5x's. They're both plus 5x, so we subtract. But here, notice how they were kind of the same term. One was the opposite of the other with these y's. What do? We don't subtract them because they're not exactly the same. We add them to eliminate. Okay, so that's why I'm trying to take you with this. Okay, these y's were exactly the same. They're negative 5y terms, and the only way you're going to eliminate them is to subtract. And if you do that, you can see you're going to get 2x, 6x take 4x, 2x, minus 1, minus 9, okay, is going to be minus 1 plus 9, which is going to give you that 8. Divide both sides by 2, x is 4. Substitute x equals 4 in 1. Again, you can substitute in any one you like. I've substituted it in 1. Do all of that calculation, and y comes out to be 5. Okay, so x is 4, y equals 5 at the end of the day. All right. Now then, one more on this slide here. Question 4. Okay, just bear in mind what I was telling you about what to do, add or subtract, depending on the nature of the two terms that were either exactly the same or opposite in sign. Okay, so number 4, you should be able to quickly rocket through this one. Okay, go for it. And then after this, I'm going to give you a GCSE question. And it's going to show you how we can apply simultaneous equations to a geometrical problem. Okay, so you might want to hold on for that. See how you get on. Right, okay, Bushy coming in with an answer. Okay, well done. Okay, others? Anybody else out there having a go? It's good to just put you under a little bit of pressure here, but if you get it wrong, it doesn't matter as long as you can see where you've gone wrong when I display the solution. Okay, Din coming in with 2, negative 3. Well done. Okay, we're going to move on. Okay, you are right, so it's great to see those answers. What do? We add the two equations because we can see that the y terms can get eliminated. They're not exactly the same. They're not both plus 6y's or both negative 6y's. They are different. They have alternate signs in front of them. So the only way to do that is to add them. And that will cancel those y terms out. We got 7x plus 2x is 9x. 32 added to minus 14 is 18. So divide both sides by 9 and you get x equals 2. Substitute x equals 2 in 1 and you can see that we end up with y equals minus 3. So great stuff for taking part there and getting that answer correct. So I did promise then we got last one here and it's going to be a GCSE question. It's on the geometry of a circle. And we've got the figure below shows a cyclic quadrilateral ABCD, and you can work out the values of x and y. So I'm hoping you know something about cyclic quadrilaterals, okay? Just quickly, you might be wanting to carry on with this one, but for those out there who don't know anything about cyclic quadrilaterals, what do you know about the opposite angles, the x and the y, the 2x plus 30 and the y minus 60? Anybody? Just enter. What do you know about the opposite angles? Okay, the x and the y and the 2x plus 30 and the y minus 60. Great. Bush's come in and she's just telling us then, and she's correct, okay, that opposite angles add to 180 degrees. Okay, so opposite angles add to 180 degrees. Let me just put that down for you. There we go. With these arrows here, opposite angles total 180 degrees. So you should be able to build up a couple of equations, okay? A couple of equations. What do you think those equations would be? Let's enter those in. You still might want to carry on, but enter it in if you can tell me what those two simultaneous equations would be. And give us a go for those that might be holding back on this. Okay, Bushy's given us a final answer. Okay, interesting. Okay, others of you might disagree. I don't know. Okay. So we're getting those answers. Yes, x equals 30, y equals 150. That's the answer that we're getting. Okay. Guys, okay, we're getting that answer there. That pair of numbers, okay. It's interesting to see that Bushy has got x is 50, y is 130. And this comes back to my first point. X plus y equals 180, and yes, 50 for x and 150 for y would make 180. But is it the solution that holds out for this pair? Okay, so let's put these equations up then. Form these simultaneous equations. The first one, x plus y equals 180, and the other one is this pair, 2x plus 30 plus y 60 equals 180, and I've simplified it to 2x plus y equals 210. Okay, so there's our two simultaneous equations, and if you work through this you'll find that the y's are exactly the same in both equations. So we know by now that you would want to subtract them. You could either do equation 1 take away equation 2, or equation 2 take away equation 1. Again, it won't matter, you should get to the same answer. I've decided to do equation 2 take away equation 1. The reason being that these numbers in here, the 210 and the 2x, are bigger than the values up here. Okay, the x and the 180. It's up to you which way round you do it. You just learn this with experience, which is the best way. 2 take away 1 leads us straight into 2x minus this x gives us the x, and 210 minus the 180 gives us the 30. So x is 30. All we need to do is substitute that value, x equals 30, into one of our equations, and I've decided to sub it into equation 1. And so we've got 30 plus y equals 180. Take away 30 and you end up with y equals 150. So therefore x equals 30, y equals 150. Okay, so I hope you found that of value. All right, and here we go. Come back on. All right, okay, so it's just a little over 30 minutes. And as I say, the point behind this particular live stream was just to introduce you to simultaneous equations, that they are equations, well at this level anyway, with two variables in, x and y as we've seen, and they have to be what we call independent. They must not be a multiple of the other one, okay, in order to get a unique solution. And I've shown you hopefully how we can eliminate a variable, x's or y's, and arrive at a solution. So that's the intro anyway, okay, and Michael will take you on to the next stage on Wednesday on how we can push this further. So I hope you'll join him for that, and that just leaves me to say have a good day. Thanks for taking part if you've done that, okay, with your answers. Thank you to Michael from Air Maths Tuition for helping out with the live chat, and yeah, I will be on tomorrow with some pure maths integration for you AS and A level guys. Okay, so see you tomorrow. Have a good day. Bye.